So we've been doing quadrilaterals, specifically parallelograms, and we're going to focus on that with our proofs. So we're going to go back. All of our proofs are going to be like you're basically going to know the statements or most of the statements, and then you're going to have to come up with the reasons. So we just want to start with going into proofs. So given that angle 1 is congruent to angle 2, again, always when you can, label the information that you know. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Now, you should already be thinking, what are those? What are they going to mean? So ultimately, you know that those are alternate interior angles. And we use alternate interior angles when we have lines that are parallel. So my goal is to prove that this is a parallelogram. So I'm kind of already formulating a way that I need to do that. So angle 1 is congruent to angle 2. I know that because it was given. Now, what does that mean? If angle 1 is congruent to angle 2, that means that BC is parallel to AD. Because if alternate interior angles, and so we can shorthand this, if alternate interior angles are congruent, like angle 1 is congruent to angle 2, then lines are parallel. Then we know that angle 3 is congruent to angle 4. If angle 3 is congruent to angle 4, because that's given, that's why we know that, then AB must be parallel to CD. It causes that Z, right? We can see this Z right here. And then earlier with that other one, we had this Z right here. So again, if alternate interior angles are congruent, then lines are parallel. Now, notice that I have two pair of parallel lines and another pair of parallel lines. So ABCD must be a parallelogram because both pairs of opposite sides are parallel. And that's one of the things that it takes to be a parallelogram. So remember, you always start with your given, and then you work through until you can use your prove. Let's say you've proven your statement without using your prove part as your proof, right? You don't want to define the word with the definition, with the word. DB bisects AC. So here is DB, and it bisects AC. So DB cuts AC in half. So that's what I'm going to mark. I'm going to go ahead and mark that because I know it. And then I've been given also that angle 1 is congruent to angle 2. So I kind of already have a plan for where this is going. I know that that diagonal got bisected. It'd be helpful if the other one could be bisected. I also know that 1's congruent to 2. Those are alternate interior angles. So I figure some parallel lines are going to come in there somewhere. So DB bisects AC and angle 1 is congruent to angle 2. I know that because it was given. AE is congruent to EC because that's the definition of bisector. AD is parallel to BC. So I'm going to go ahead and mark that. AD is parallel to BC. Why do I know that? Because if alternate interior angles are congruent, then lines are parallel. We started knowing that the angles were congruent, and we needed to use that. Okay, then I know that DEA, angle DEA, now we're trying to think about where we're trying to go with this. If I could get DE or DA, either way, if I could get DA congruent to BC, then I would have one pair parallel and one pair congruent. If I could get DE to be congruent to EB, then I would have the diagonals bisect each other. But I need to look at the direction that this says I'm going. So this says DA is congruent to BC. So that's the direction that I'm going. So I need to pull some information. So DEA is congruent to BEC. So DEA is congruent to BEC. Well, why do I know that? Because those are vertical angles, and vertical angles are always congruent. So now I can say that triangle DEA is congruent to triangle BEC because ultimately I want to talk about the rest of the pieces. Well, I only need 3 pieces to prove the triangles are congruent. They're congruent because of angle, side angle. Now, from there, now I can say what I wanted to say was that DA is congruent to BC because of corresponding parts of congruent triangles are congruent, CPCTC. So now when you look at what you have, why do I know that ABCD is a parallelogram? Well, remember that very last statement said that if you have one pair of sides that is congruent and parallel, then it is a parallelogram. And since I have AD is parallel to BC and AD is congruent to BC, that means that ABCD must be a parallelogram. So let's look at number 3. Angle 1 is congruent to angle D, and angle 1 is also congruent to angle B. So I want to prove that quadrilateral ABCD is a parallelogram. So let's look at the direction of the proofs. One's congruent to D, one's congruent to B. I know that because that was the first part that was given. So AD is parallel. So AD has to be parallel to BC. AD is parallel to BC, so I have to look at why. Why do I know that? Well, because angle 1 is congruent to angle B, and those are corresponding angles. So if corresponding angles are congruent, then lines are parallel. And then AB, right here, AB is parallel to DC. Why would I know that? Well, because those two angles are on that transversal. We have to cross between the parallel lines. And, whoop, I forgot, AD was parallel to BC, and AB is parallel to CD or DC, because if alternate interior angles are congruent, then lines are parallel. So I know AD is parallel to BC. I know AB is parallel to CD. So then that means that ABCD must be a parallelogram because both pair of sides are parallel. All right, number 4. I know that ABCD is a parallelogram, so I'm telling you that ABCD is a parallelogram and all the things that come with it. And I'm also telling you that AE is congruent to CF. So let's look at our steps that we were given. So we know that the first step is always our given. Angle A is congruent to. So based on what we have, angle A, because this is a parallelogram already, angle A is congruent to angle C because opposite angles are congruent when it's a parallelogram, like that one is. AD is congruent to BC. Again, we know it's a parallelogram, so we know that opposite sides are congruent. Now, I can prove, now what we're trying to prove is, our goal is to prove that this is a parallelogram. So we've got to think about kind of what the things that we need to happen for that to happen. So the easiest place to go is, let's say that these triangles are congruent, because if I can say that ED is congruent to BF, that would be helpful. So I can say that AED is congruent to CFB. The order of that does matter, and so you want to kind of go the same direction that you went on the first one. Why is that? Because of side, angle, side. So now I can say ED must be congruent to BF because corresponding parts of congruent triangles are congruent. So now I know those two are congruent. All right, well, now I need some more information. I don't have any way of getting, I don't have anything about the angles, so I can't use anything parallel. So I need to get some other piece of information. Well, I do know that because it is a parallelogram, I know that AB is congruent to DC. Okay, that's opposite sides are congruent again. But now we're talking about a different set of sides. So then if I were to take, and we don't have this step, but if you look at this, if I were to take AE and add EB, right? That's AE and add EB. And then set that equal to CF and DF. So add those two pieces. Well, way back up here, I know that AE is congruent to CF, so I could replace that with AE. Well, now, if I subtract AE from both sides, it leaves me with EB is congruent to DF. So I can use the subtraction property. So you could have inserted several steps in here to where you would have your addition property, then you would have your substitution property, and then your subtraction property. And then from there, now I know EB is congruent to DF. It's also the property of addition, like if you're adding, if you add, if two congruent segments and then you have two congruent segments, like I have this congruent segment and I take away that one. That's basically what we're doing with that subtraction property. So EBFD is a parallelogram. Now, I know that yellow part is a parallelogram because both pairs of opposite sides, we need to say that, both pairs, because it does take both pairs of opposite sides are congruent. So you want to look at the direction that your givens lead you. You will have statements that are given where you can fill them in, and then you'll come up with the reasons for why it's a parallelogram. You need to keep in mind when you get to the part of the proving where you want to prove that it is a parallelogram, it's got to meet one of those 6 statements that we said in the very beginning of what it takes to be a parallelogram. Opposite sides are congruent, opposite angles are congruent, opposite sides are parallel, consecutive angles are supplementary, the diagonals are bisecting each other, or one pair of sides is both congruent and parallel. Any one of those can be used to prove that a quadrilateral is a